Hello, hello. Today we're going to be looking at instancing geometry in TouchDesigner. We will be using noise as an input to drive the rotation, color, and some translation of a grid of these capsules. So we'll be using instancing to do this, as I mentioned, and this is a powerful technique in TouchDesigner. It lets us take one piece of geometry and draw it over and over again on the graphics card or the GPU. This is much more powerful than, say, doing it on the CPU with something like a copy SOP, because it lets us kind of manipulate them, transform them, move them, scale them all in real time. So this is running somewhere between 50 to 60 frames per second, mostly due to the screen space occlusion, but if we drop that off, we could easily get 60 frames per second. So you can see how, in this case, we're working with 10,000 instances and it's all kind of running very smoothly. So yeah, we'll be looking at how to create CHOP data, which essentially each one of these 10,000 samples corresponds to one of our instanced geometries. And yeah, we'll look at how to create this CHOP data and work with instancing, building the network from scratch. So we'll ultimately end up with something like this. But I'm going to go ahead and close this and we will start from a new document, new TouchDesigner. So, all right, the first step here, we're going to start by creating that kind of capsule, that tube with rounded caps. So I'll go ahead and create a tube. Oops, I put a Y there first. Tube SOP. And this is much wider than we want, so I'll go ahead and bring the radius down to 0.025. That's what I had in my last example. So we have this nice, tall, skinny tube. I'll leave the height the same for the moment. The next thing we're going to want to do is to add those rounded spheres on the ends. So what I did for this was I merged a few pieces of geometry together. I will set this to orient on the x-axis just because that's what I did in my last example, but it really doesn't matter as long as you're consistent. I'll go ahead and create two spheres. Well, first one at a time. This first one, and then merge it with a merge SOP. So I'll connect both SOPs into this. You'll see that the sphere is as wide right now as the tube, and we need it to be quite a bit smaller. We actually want the radius to be the same as the tube, and one really quick way we can do this is through Python expressions to access the parameters from our tube, so that whenever we change the tube, our spheres automatically kind of change in their radius and position. So this gives us a lot of flexibility. If we do kind of map in external inputs, we can only change the tube and it will change the entire kind of capsule all at once. So the way we do this is for our radius, we're going to reference the tube first. So this is through OP, parenthesis, hash mark, and then tube1. So we're typing the name of the operator. We're going to close the kind of single quote mark and parenthesis. And then now we want to access its parameters, which we do by typing dot pair or PAR. And then specifically, we want the radius. I can't just type radius. I actually need to kind of click it to drop down and see what it's actually called, what its name is instead of its display name. So we want to reference rad1 in this case. So I'll go ahead and type pair dot rad1, and there you go. So we can even see that it's kind of like networked. This exporting data line shows up to show us that we're referencing the parameters in tube 1 from our sphere. I'll copy this for each of the radiuses. I'm never going to make this kind of like ovoid. I'll keep it as a circle so I don't have to worry about kind of keeping these consistent with the two radius parameters here. And there we go. So this is now the same radius as our tube. However, it's stuck in the middle. So we need to also position it so that it fits at the end of our tube. So I'll go ahead and copy our sphere. No, not yet. I actually need to center it. So I'll use that same technique here. OP tube1.pair. And then instead of grabbing radius 1, we're going to grab the height this is conveniently just called height. If we look over here, click the drop down, height, and all right, where'd it go? Looks like it's positioned from the center here, so we actually want half of the height. So we can actually do all of that in our Python expression, just divide it by 2, and there we go. I'll hit H to home, and we can see we've got ourselves a rounded cap here. And then we need to do the same thing for the other side. So I'll go ahead and copy sphere 1, plug it into my merge 1, and instead of kind of positive, we want this to be in the negative axis, so I'll just type negative in front of that 2, and there we go. Dividing by negative 2 throws it in the negative axis. So now you'll see if we change our height, we're automatically seeing the spheres move, and same goes for the radius. If we bring this up or down, we get a corresponding change in the radiuses of the spheres. Great, so our capsule's done. Now we just need to plug that into a render network. So I'll right click on this merge 1, grab a geometry comp, here we go, and then I want a render top. We'll make this 1080 by 1080, can be whatever you want. We also need a camera, as every sort of rendering network needs. And let's also make a material. So this one's going to be a constant. This is because I'll be using screen space ambient occlusion to shade, provide shading. So I don't need a light for that. However, you could try this with a Phong and a light, or PBR, whatever you like to do for rendering your materials. Experiment with different things. But this specific effect is going to be using a constant and SSAO. So we'll continue with our screen space ambient occlusion. My last tutorial on noise displacement kind of went deeper into this operator, so I'm going to sort of gloss over the details a bit. I know kind of what worked for that last example after tweaking it a little bit. Certainly you can play with these parameters more yourself, but we're going to do 30 for the sample directions, and we'll keep the steps around 15. I'll bring the surface avoid angle down to 0, choose full for the pass resolution, 0.16 for the radius, and 0.5 for my contrast. And then I don't want to blur this very much, maybe like 0.5 and no sharpness, which honestly I don't ever really see this do anything, to be honest, the blur sharpness. I've never noticed any effect, but you might, so that's just at 0. Okay, so nothing yet because we need more geometry for it to actually create any sort of shading based on occlusion. So we're just gonna leave that here for now. We'll see it take form later, and then I'll create a null, which is basically what's the end of my network here. So I'll click the display flag. However, I don't want this to show up in the back of my network. That'll make things a little bit more cluttered. So I will split the screen, drag this to the left, and on the right side, display, uncheck backdrop tops on the left, choose the top viewer. So we just have our output on the left, and we can see our network on the right. So there we go. We've got our render network set up. So now the next step is to create our instancing. We want this to be a grid of tubes. That's what I did for my previous example. So we can get those point positions actually using a SOP. So we're going to start with a SOP and then kind of move that to CHOP land. So we'll grab a grid SOP here. And my example had 100 by 100 for the rows and columns, which is going to give us 10,000 tubes. And then also I'm going to increase the size a little bit here to 6 by 6, just so that it shows up in the camera. You can certainly, change these to your liking, but this is what I had in my last example. I'll place a null after this. Just means if I want to swap inputs, it's kind of easy to do that. And then from the null, we will convert this using the SOP to CHOP method, and here we go. We've got TX, TY, and TZ, 3 channels, 10,000 samples. So each one of these samples is going to represent one of our instances. And we don't actually need the Z here, so actually I'm going to go ahead and use a select to only select my TX and TY channels. We'll use noise to plug in the Z direction, kind of move it forward and away from the camera. So for now, let's just use our X and Y positions. And then lastly, I'll grab a null, and this null is going to be our kind of end destination for our instances, so we can just send things into this, keep it consistent. I'll call it instance, just good to keep things organized. And in my geometry, I need to go to this instance tab. You'll see that it's by default is off, but we'll toggle that on and then drag our instance chop null, our instance null chop, to the instance chop.sop, so you can actually use dats or sops to do this too. I mostly use chops, but it's really up to you. It all works the same. Now we will see that nothing happened initially, so we need to tell it what channels in our instance chop we want to correspond to these different parameters to move, rotate, scale, and kind of basically manipulate all of our instances. So in this case, the names line up, right? TX, translate X, TY, translate Y. We're basically moving those around in space. So I'll just type TX and TY here. Another way you can do it is with this caret drop down. So if you don't like typing as much, or you have really long names to type, this is just a way to see exactly what channels you have in your instance chop. Handy way to grab them. So you'll see we've already got our instancing is happening. It's instancing these tubes on the grid. If we made the tube shorter, there we go, we can see now we just have our spheres, that we've got ourselves a grid of spheres. I'll make that back one again. So now it kind of looks like window blinds when it's at full length, but we want to, eventually we're going to rotate that in a moment. So that's sort of our next step, is we want to kind of generate some rotation, and to do that we will use a noise top, specifically a top because our instances are in a grid layout, and so by creating a corresponding grid to define their rotations and colors and things like that, we can corresponds very directly. So under the common page, let's make this the exact same size. You could certainly link those with Python if you want to, or have some external parameter that's kind of changing the size of everything. For now, I'll just leave it hard-coded. And yeah, we've got ourselves our noise. We also want this to be RGB noise, so we can use each of those channels to drive different things. And then I will go ahead and connect this to a null. Handy to always connect things to nulls at the end of a network before we kind of change it into something like SOP data. That way, if we want to swap out, or that was CHOP data, if we want to swap out any kind of like other noise sources or blend between things, we don't have to change these network connections. So I'll go ahead and take from this null, top to chop, and there we go. We see this is one row of our pixels being turned into chop data. We actually want the entire image, so I'll go ahead and click full image. You want to be careful with this, depending on how large your texture is, how large your top is in terms of its resolution. This could really either cause your computer to hang or crash. Like if it's a 2000 by 2000, that's quite a bit more than 100 by 100. Okay, but we have our channels now. You can see R0, G0, B0, and A0. It's our red, green, blue, and alpha channels, and we've got one channel for each row, essentially. So we get quite a few channels, 400. We want to reformat that so that our red, green, blue data are all in one channel, like the TX and TY. So to do that, we can use a shuffle. This is a super useful chop. And we're going to be using the sequence channels by name. So what this does is it looks at the name of each channel. So if it's R0 and R1, it considers those to be the same name, and then it just like lines them up after one another, which is the same method this is doing. You can see that you know, this, because this TZ is spiking like a kind of like it's a sawtooth wave because we're swiping across the grid. So each one of these is a different row as the TY kind of moves vertically, right? So we're moving up each row in steps. So that's how we want our noise to be translated as well. We want it to be stacked in a line. We don't want our alpha, I mean, you could use, well, it's just flat, but so we're just gonna delete that from the kind of RGB mapping. We're just gonna grab those. We don't need alpha. So great, we've got ourselves some noise data. And the next step is we want to plug that into our instancing network. I'm going to go ahead and rename these now as well. So I know that I want this to be my rotation, and the green is going to be TZ, the translation in the Z-axis, and then blue I can use for color. So now we've got those named appropriately, and it'll make things easier when we then link it up at the end. Not really a necessary step, I just like to keep things tidy. So out of the shuffle, I'm going to make a few select chops. So this first one, I just want to rotate, and then I'll copy it. We'll grab TZ, and then I'll also, this select, I know I'll want it later down here to do my color. You could keep it all in line if you want. I sometimes you know, use this method to select chops just because it can kind of avoid a lot of like patch cables, which get pretty messy. So we'll get to the color in the TZ translation in the Z axis later. Let's just focus on the rotation for now. So one thing I want to do before I plug it into this instance null is range it. So I'm going to use a math chop to do this. This has this range tab that lets us basically remap values that are going from 0 to 1 to another desired range. And in this case, 0 to 1, it's not really going to kind of give my give a lot of, like, if that's a degree, that's only 1 degree of rotation. So we really want to make this a little more dramatic. So I'm going to rearrange it from negative 180 to 180. So we're getting quite a bit more rotation. One thing I didn't do with the noise, you'll see how this kind of chops off. It's like kind of like clipping the top of the noise. This might be what you want to do, but I like a little bit more resolution because this is a 8-bit fixed noise. I'll often use, if I can, 16-bit or 32-bit noise. You'll see, I should actually show you here, going between the two, we get quite a different look. We're actually seeing these peaks go above 1 and below 0. So it gives us a little bit more, less like, you know, we don't know that it's between a specific range, but it's going to give us a higher resolution as far as our bit depth. So more values to represent each pixel, or each value in this case, as we move those over from red and green and blue to rotation, translation, and color. All right, so back to this. I kind of got sidetracked there for a second, but we've got our rotation data, and now it's ranging from somewhere, in this case it's like negative 340 to 319. So we've got a solid rotation, and then we also need to merge this into our instance. So we'll use precisely that, a merge chop. I'm gonna go ahead and plug in our math here, and we'll see now we've got a rotation channel feeding right into our instance null. So to rotate this, I want to rotate it around the z-axis because that's the axis that's pointed, the camera is pointed at, so that everything rotates where we can see it. So I'll just type in rotate. All right, and there you go. It started rotating. We don't see the shading quite yet. So to do that, we're going to need to use some movement towards and away from the camera as well in this TZ or translate Z parameter. So I'll actually create another math here. And in this case, you know, this can be really whatever you want as well, but we'll go from -1 to 0, just so that it's only moving away from the camera. We don't want to get too close and to the camera at this point. And then we'll plug that right into our merge as well, and type that into translate Z. All right, and there we go. We've got something that's starting to look a lot like what we had in that first example I showed. Going to our noise, we can bring up the period a little bit, and there we're starting to see kind of exactly the effect that I was going for. We're also going to want to transform this a little bit, so under the transform, we'll use our handy abs time.seconds. Oh wow, super fast, but it's a good Python expression that just grabs the absolute time since we started the program. I will multiply this by 0.1, and we've got our noise slowed down quite a bit so we can kind of see that motion a little bit clearer. You can refine that as you like, but now we've got some motion happening, so that's kind of nice, looking like what we had before. So really the last step here is the color. And right now we just have values that are ranging from around 0 to 1, maybe negative 0.5 to 1.5. So we want to take this and somehow turn this into color. So one nice way to do this is using a ramp top to first generate like a gradient of color. So my example originally used kind of a rainbow going from red to blue. Some green in there too. Let's see. I think I even got to a darker blue by the end. Cool. You can tweak this as you like, play with the colors a little bit, see what you can do, but this is good for now. And I'll plug this into a null. It's always great, as I said, leave a null at the end of your chains. If we want to copy this, create other colors, it's really easy to just plug that into a null instead of changing around different things that are mapped. So from this null 4, now I'm going to convert this to CHOP data. So now we've got 4 channels. We don't need alpha because we're going to have these all opaque, so I'll just leave RGB. And then we need now a way to take this CHOP data and reference different colors. So each one of these slices is basically one pixel in a row. So to do this, I'll use the Lookup CHOP. This is similar to my last tutorial that I used the Lookup top. Same exact principle, but it's happening in the CHOP world or CHOP land. So now if I just plug in this first one, which is the index, it takes these values ranging from 0 to 1, and based on what the value is, it just looks up each of these channels ranging from this whole like 1 to 251 in this case, but really doesn't matter. It's going to look at the whole range of your incoming samples. So 0 is going to correspond to red, or the rightmost side of this top, and then any values that are at 1 will correspond to the rightmost side. You'll see you also have the ability to modify the index range. So if we wanted to even make this negative 0.5 to 1.5, we can see how we can actually make use of some of those values that peak. I'll leave it as 0 to 1 for now, but you can certainly play with that range as well to get kind of different color mappings. And that's all we need to do to generate our color data. We've got our RGB channel now, channels, and so I'll plug that into the merge, and then the last step is to map those channels to the corresponding parameters in our instance tab. So you'll see on that first instance we only have translate, rotate, scale, and pivot. So we'll want to go to instance 2, where we've got our texturing, color, instance textures, all super useful ways to recolor or texture our instances. So in this case, I'm going to use RGB in the RGB color mode, and there we go. We suddenly have this gradient coloring those tubes based on one of these channels of noise. So from here, you can certainly explore quite a bit. One thing we could do, something I actually did in the original example, was instead of using a separate source of noise, I used the same rotation data to color the same tubes. That's kind of a nice way to link certain parameters, so there's sort of a relationship between the color and the motion. It may or may not be desirable. We could also use TZ, which creates kind of a height map, so things that are closer to the camera are blue, things that are further away are red, depending on how you map it. So this is something that you can definitely play with, whether or not you want to create relationships between different channels of data. Another key thing to play with is this noise input, or really any other texture input you want. It doesn't have to be noise, but in this case, we could play with the period. So even just dropping this, we're going to get some like denser spirals here. The amplitude as well will give us changes in the intensity of the noise, and likewise the intensity of the spiral. What just happened? Oh yeah, 0.5 is what I had before. And then, the next thing too we could do, I'll actually close these off here. We don't need to see the data. It's going to help our frame rate a little bit. We could also play with the tube itself, which, if you recall, it's going to change the spheres. So playing with the kind of the height of the tube will give us some different effects, or even the radius here. You'll get some, that one's kind of cool, like a sort of scaly look. It's a little bit different. Additionally, if we wanted to, we can play a little bit with the camera. So if we wanted to say, here's the camera, zoom out a little bit, we can start to see the form, like the edges of our actual grid, which gives it sort of a nice like actual form, as opposed to just this amorphous texture that bleeds off the edges. So some things that you might like to play with. Also, these math chops here that are ranging our rotation and our translation values. Certainly we could increase these as well. So bringing this up to say 360 and doubling the amount of rotation is going to give us a denser rotation. Or if we wanted to say move some of these further away from the camera, bringing them back, we start to get kind of like extreme vertical displacement. So these are all things that you can play with as you explore this network. So that's pretty much it for today. I hope you got something out of this tutorial, and thanks for watching. Until next time.